Hi, today we're going to talk about arithmetic sequences. So an arithmetic sequence is basically a list of numbers that we have that all carry a common difference between each term. So what I mean by this is if we had 2, 4, 6, 8, 10, that would be an arithmetic sequence because we have an addition of 2 in between each term in our sequence. So that would be a sequence here. If we had an 11 here instead of a 10, then that would make this a 3. And so this would not be an arithmetic sequence because the value that we are adding between each of these numbers would not stay constant. Now that we have all that down, I've written another sequence on the board. And now we're going to ask ourselves, what happens if we wanted to find a very large term that was way off into the distance within this sequence? So for example, what would happen if we wanted to find the 41st term in this sequence? The A represents that it's a term within our sequence, and the subscript of 41 represents that we want to find the 41st term. And so there are equations to help us with this because by hand, let's face it, by hand this calculation would take a very long time. So we have a formula to help us, and the formula is a sub n, where n is the term that we want, in this case would be 41, equals the first term of the sequence, in this case that would be 7, plus the quantity n, in this case 41, minus 1 times d. And d is the difference between each consecutive term. So in this series, or in this sequence, it would be 3. So if we plug in everything here, a sub 41 would equal 7 plus 41 minus 1 times 3. And so if we simplify this a little bit, a sub 41 would equal 7 plus 40 times 3, that'd be 120. So we'd have 127. And that would be the 41st term of our sequence. Let's try a bit of a trickier one. So here we are not given the arithmetic sequence, but instead we are given specific terms from this sequence, and we are asked to find an unknown term here. In this case, it's a sub 13, the 13th term. We're given the 5th term and the 3rd term. So how are we going to deduce the 13th term from the 5th term and the 3rd term? Well, remember that we have our equation, handy-dandy equation up here that we can use. And so starting with this piece of information, we know that for the fact that the 5th term equals 12, we can say that 12 equals a sub 1, we don't exactly know a sub 1, plus 5, which is n in this case, so 5 minus 1 times our distance between each term. And then for a sub 3, we can write 6 equals a sub 1 plus 3 minus 1 times d. And so if we simplify this a little bit, we get 4 within this parentheses. So there's a 4, and then we get a 2 in here. So there's a 2. And so now what we have ourselves is a system of equations. We have 2 equations, 2 unknowns. And so now we can use our regular equation solving techniques to finish this problem off. In particular, I'm going to subtract this equation from this equation. So let's see, we have a 6 here. 6 equals, these two cancel out, and we're left with 6 equals 2d. And so we see that d must equal 3. And so plugging this back into, say, let's take this equation right here, we can find that 6 equals a sub 1 plus 2 times 3. So a sub 1 must equal 0. And so now we can build this equation here for the general term, and we can say that a sub n equals, well, we know that our first term is 0, so a sub n equals 0 plus the quantity n minus 1 times 3. And so if we want to find the 13th term, all we need to do is plug in 13 for n. So a sub 13 equals, this is 0, 0 plus the quantity 13 minus 1 is 12 times 3. which would give us 36. So that is how you solve those types of problems.